Question 7, ChemWiki, end of chapter material. Stainless steels typically contain 11% Cr and are resistant to corrosion because of the formation of an oxide layer that can be approximately described as FeCr2O4, where iron is F2+. The protective layer forms when Cr2+ is oxidized to Cr3+, and Fe is oxidized to Fe2+. Explain how this film prevents the corrosion of Fe to rust, which has this formula Fe2O3. It is important to know that corrosion is oxidation, which is easier to reduce and harder to ionize. So based on the question, I have to explain how this film, Fe2O3, prevents iron from rusting. First of all, I'm going to go back to the question, which gives us which describes the protective layer to us, how it forms. So I'm going to write that down for you guys. It forms when Cr2+ is oxidized and to Cr3+. I'm going to write this out for you guys. Cr3+ AQ aqueous plus E- yields to Cr2+ AQ aqueous. The other one, it says Fe is oxidized to Fe2+. So Fe2+ AQ plus 2E- yields to Fe solid. And there. Okay, so these are reduction half reactions, and and the standard reduction potential chart and table has the values for these reactions, which is stated as a negative 0.41, and it's stated as a positive 0.771. These, once again, can be found in the standard potential, standard reduction potential chart table, which can be found in the back of your book or on the Wiki ChemWiki page. Okay, so we will use these values to determine which of these two is most likely to oxidize. If it oxidizes, then it will corrode, based on the definition of corrosion. So my method to determine which one was most likely to oxidize or to go through oxidation is by looking at where they are placed on the chart, the standard reduction potential table. So we know that the standard reduction potential table decreases by value. So it's plus values, and then you'll get to the negative values. And we know that Cr3+ reaction has a negative value, and Fe2+ to Fe solid has a much higher value. So Fe2+ aqueous plus 2E- Fe solid has a positive 0.771, and the Cr3+ AQ plus E- to the Cr plus 2AQ has a negative 0.41. Okay. So it is said that you look at the one that's the highest which is Fe2+, and whichever one, if it has one that's below it, so Cr is below Fe2+, then this one is the most likely to go through oxidation, which in turn means this one is most likely to go through reduction. Okay, and so based on the equation, based on the definition of corrosion, corrosion is oxidation, which is easier to reduce and harder to ionize. So Cr plus 3 will be most likely easier to reduce than Fe2+. So that's why iron will not rust, because the film, that's how the film works. Cr will corrode and leaving iron intact. So that's why the film prevents iron from rusting. Because based on the standard reduction values, of these two reduction half reactions, Cr is most likely going to oxidize, meaning oxidation, which in turn means corrosion, which leads to rusting. And that is why iron does not rust.